All right, so in this first guided practice problem for kinematics, you have a situation about a car traveling on a straight line. See the problem up there at the top. So the first step that we always do to solve problems, and what I'll expect that you do when you're solving problems in class, is that we write down, we annotate the problem. What are we solving for and what are we given? So in this problem, we're seeking the time. It says, in what time interval did the acceleration occur? When we look at the units in the context of the problem, we know that we're given two velocities. The car is traveling with a velocity of 5 meters per second, so that means that that's the initial velocity, v sub I, and that after an acceleration, so after the car's velocity is 8 meters per second. So that's the final velocity, which we just call v. We also are given an acceleration, which you would know that that's an acceleration two different ways. One, the units tell you meters per second squared are the units for acceleration, but also it just says in a straightforward manner that an acceleration of. So we've annotated what we have. You could draw a simple diagram if you want for this problem. It's very helpful to illustrate problems in a simple manner, just to, even if you're just drawing an arrow, to visualize what's happening. The equation that we're going to choose for this is listed there. So you see the note on the screen. If I look at each term from left to right, I look at v. I know velocity. I've listed it up there in the annotation. vi, I know that. That's 5. A, that's also given. Time is the only variable in this equation that I don't know. So I have one equation. I have one unknown. And importantly, that unknown is something that I want to solve for. So it's possible to have one equation with one unknown, but the unknown is not something you're interested in solving for. So we don't want to waste time doing that. So this equation is perfect for what we need. So next we're going to substitute values. And you notice that the only value, again, that we didn't know was time. So I left t for time because there was nothing to substitute in for it. If I do the quick algebra, so everything else from here is just algebra. So if I do the quick algebra, by subtracting 5, I've got 3 equals 0.75 t. The t and the 0.75 are multiplied, so I'm going to divide, get t by itself. Rewriting that, and our answer is 4 seconds.